This problem is asking us to find the limit as x approaches 2, and then they put that little negative sign up in the exponent, so that means from the left, of 1 over x minus 2. So we are looking at a left-hand limit of 1 over x minus 2. What I always tell people is try option one. My option one is you always just want to take, and whatever x value you're headed towards, you want to go ahead and plug that in and just see if it works. Sometimes it will, sometimes it won't, but it happens often enough that it is worth your time to always just try it. So we end up with 1 over 2 minus 2 in this situation. That doesn't help us because we end up at 1 over 0, and really it's this division by 0 that's telling us that option 1 failed us. What you're going to find in a problem like this is none of our other standard limit options are going to work. We can't factor and cancel here. We're not seeing absolute values or complex fractions. And so really when all of your other limit options break down, you're probably looking at a vertical asymptote. And you're probably going to have to, the only game really left is to play what I call the big small game. So this is a very conceptual way of finding the answer. The problem with these for a lot of people is the fact that there's no algebra, step by step, do this and you'll result in the final answer. This really is something you've got to sort of mentally work your way through. It's not bad, but it's not just going to be the same sort of like plug and chug that you're used to. So we say limit as x approaches 2 from the left of 1 over x minus 2. The way the big small game works is I'm really going to be doing kind of the same thing that I was doing on option 1. I want to find a number that's coming really, really close to 2 from the left. And I'm going to plug that in for x in this problem. So if you think about this in terms of a number line, if 2 is right here and I'm coming at 2 from the left, a number really, really, really close to 2 is going to be 1.999999999, right? The closer I get to that 2, the more 9s I put in there. And so now what I'm going to do is I'm really just going to be plugging in 1.999 and sort of see what comes out of there. So I get 1 over, instead of x, I'm plugging in this 1.99999. I'm doing this here all by hand. On a test or on the exams, you probably would just do a lot of this work sort of mentally once you get good at this. But this is really just to show you how this all breaks down. So as we come to start seeing what this means, we start cleaning this thing up. On the top I have 1. And when I look at the bottom here, this 1.99999 minus 2, well, 1.99999 is always going to be smaller than 2. So we know that number is going to be negative. And if you think about it, it's just negative and then a decimal point, and it'll be a ton of zeros, 0.00001. How many ever 9s you go out is how many ever zeros you're going to get, right? And so what we now can do is we really can start visualizing what this is saying to us in this big small world. So on top here, I've got a 1, which is a positive big number. 1 compared to that decimal on the bottom is huge, right? On the bottom here, I have a negative small number. If we look back up to the numbers up here, what we can see out of the numbers is if you did this, this number would just be huge. If I did 1 divided by a really small decimal, if you type that into your calculator, that thing is going to blow up to 10 million, 100 million. It's just going to keep getting bigger and bigger the more decimals you put on it. So what that's telling us is this thing is getting large. And when things are getting large, that means they're headed to infinity. The last thing you have to consider is whether it's headed to positive or negative infinity. And so that's where the symbols that you use up in the front, whether it's a positive or a negative, matters. We had a positive big over a negative small. A positive and a negative result in a negative. So our answer on this problem is going to be that the limit as x approaches 2 from the left of 1 over x minus 2 is equal to negative infinity. Our graph is headed off. Our y values are headed to negative infinity. The other thing that this tells us right now is anytime you get an answer of plus or minus infinity on a left side or a right side, it doesn't have to be both, that tells you that you have a vertical asymptote at that point, at that x value. So because our answer was plus or minus infinity, negative infinity in this case, we know we have a vertical asymptote at our x value up here. So at x equals 2.